In this video, we are going to be talking about the change of base formula. It says for any positive real numbers m and b where a is not equal to 1, then log base b of m, which we already know the base itself can't be 1 for a general log, and that will equal log base a of m, so this same m value, divided by log base a of b, so the original base. So essentially you're going to take log of m divided by log of b. So when I say the big number divided by the small number, I mean the what you're taking the log of divided by the subscript, the base. Okay, and this is a, and it says that a can be any positive real number except for 1. So let's go ahead and look at this first example. It says approximate log base 7 of 5 to 4 decimal places. So remember my calculator here, which I had pulled up earlier, doesn't have base 7. It has base 10 and base E. Those are the only two bases that this scientific calculator has. It's true that some have more, but the general scientific calculator only has base 10 and base E. So I can't evaluate this in the current form. I have to use the change of base formula. So I'm going to rewrite this as log. I'm going to go ahead and use base 10 first. And so log of 5, right, the big number, what we took the log of, divided by log of 7. So log of the base. The base goes on bottom. So BB, the base goes on bottom. And now these have to have the same base, so they're both going to be base 10, which I do have on my calculator. So this is how I would type it in on this specific calculator, right? So remember, I have to type the number first. Some calculators you would type log first. I'm going to hit 5 log, divide it by 7 log equals. So that equals 0.8270. Look to the right, because I'm going out to 4 decimal places. I have to look at the 5th. That's an 8. So I'm going to round that 0 up to a 1. So 8271. Approximately 0.8271. Now, it didn't say that I had to choose base 10 here. Look, it just says A. Any positive, not 1 number. So I'm going to do that same problem again. I chose base 10 before, right? I didn't write the 10, but this is the common log, so I didn't have to. But I'm going to do that same problem with ln, the natural log, or base E. So I'm going to start again with log base 7 of 5. But now I'm going to choose base E. So the natural log of 5 divided by the natural log of 7. Remember that base goes on bottom. What you took the log of goes on top, base goes on bottom. And I'm going to type that into my calculator. So 5, the natural log, divided by 7, take the natural log of that, and what does that equal? Same thing, 0.827, after I round it, a 1. Oops, 8271. So I don't know how this got onto that next page, but as you can see, it doesn't matter the base that you choose. The change of base formula works for any base where a is not 1. But in general, we're going to pick either the common log or the natural log because those are what most calculators have. Go ahead and try these two examples on the right-hand side. Alright, it says approximate log base 3 of 4 to 4 decimals. So, let me move this over here now. Log base 3 of 4 is the same thing as log of 4 divided by log of the base. Right? So, base went on bottom. I have to take the log of both of those. So I'll get my calculator out. 4, take the log of it, divide that by 3, take the log of that, and what does that equal? 1.2618. Look to the right. This 5 says to round that 8 up to a 9. So 1.2619. I'm going to forget that. 1.2619. Is that what we said? 2619. Yep. Okay, so something tricky about this is if your calculator types things in the way this one does. So I hit that 4 and log. So this number here is the log of 4 divided by 3 log. Now this number is not the answer. Even though it looks like log of 4 divided by log of 3, this is actually just log of 3. I have to hit equals to actually get that division completed. Okay, so be careful with that when you're typing these into your calculator. Alright, let's look at the next one. I'm going to rewrite this using the change of base to log of 4.2 divided by log of 0.3. So now I'm going to plug that in. 4.2. Take the log of that divided by 0.3. Take the log of that. And what does that equal? Negative 1.1919. But this 5 says to round this 9 up to a 10, which means I'd put a 0 and carry the 1. And now this 1 is a 2. So negative 1.192. And you could put the 0 there to technically go out to 4 place values. If you didn't write it for me, I wouldn't count anything off on that. And there you go. That's the change of base. So you can choose any base. If you did these with the natural log, you should still end up with the same answer.